two curves. The concept is that I'm going to illustrate in these three diagrams down here. Concept is from FTC1, we know if we have a function here, we can get the area below the curve. Or if it's below the x-axis, it'll be up above the curve. So basically to the x-axis. So what we can do here is we get the area below the curve. We're on A to B, and it's in yellow. If there's another function, though, you see the line in there, g, we can get the area below the curve there. That'll be the green. So if I have this one and I subtract off this part that I don't want, it'll give me this leftover piece right here, which is the area between those two curves. And so that's what it's going to be. I'm going to do the area of, here's another example here. Area of, we would FTC1 an integral, one function minus the other function. And what it boils down to is, I would say, top minus bottom. So up here, to outline it, they say f and g, they've got to be continuous functions. Can't be a break in the graph. And it's got to be a closed interval. This is how we say top and bottom. F is the top function in this example, and g is the bottom. But in general, don't focus on that. Just focus on its top minus bottom. Okay, then the area between the curves is the definite integral from A to B of f of x minus g of x. So there's a lot of FTC1, but first you got to subtract. The other thing I want to show you is, let's see, I'll just put it down here. So what if, I drew it here, what if okay, so what if they're below the x-axis? I'm going to give you one. I want to find the area here. I'll call this, what do I call it? A here and B. Okay. So there's one function, here's the other. The area between them would be B. Right? That's just the part that's between them there. So let me show you how this works if I had this. I would still do top function minus bottom. Sometimes students think, well, it's reversed. Should I do bottom minus top? No, we still do top minus bottom. So if I do A, if I do the top, excuse me, it'd be the area above the curve to the x-axis, and it'd give me A. However, it's negative because we're below the x-axis. Okay. Then the formula up here says minus. Okay. Then I'm going to do the blue one and do the area to the x-axis here. It would be B and A together. But again, they're negative because they're below the x-axis. So it'd be negative A and a negative B. Because they're plus negative B. So I'd have B and A together there for the blue one, but it would be both negative. When I distribute this, I'll get a positive A and a positive B. And those cancel. And so I'm left with B. And that's what we thought. It was going to be just this would be the area between those two curves. So my point there is it still works top minus bottom. Don't switch to bottom minus top. Top minus bottom, if they're both below the x-axis, if part of them are, if one is above, one is below, top minus bottom. Okay. Any thoughts before we try one? The last thing I do here is I give you a general strategy, and I'm going to do this for each one. I'm going to make a sketch. Sometimes you don't know which one's on top, which one's on bottom. Make a little sketch. Use your graphing calculator as needed. If needed, this isn't on every one, find intersection points. And finally, FTC1, integrate and evaluate. Okay, so first one, find the area of the region between the graphs 4x minus x squared and x squared minus 4x plus 10 on the closed interval 1, 3. Both are continuous functions, they're polynomials. Closed interval AB there, 1 and 3. So let's see. So first I'm going to make a little sketch. And use your graphing calculator as needed. I'm just going to use Desmos. Quick sketch. Let's see. So it was Okay, so I think that's it, right? Yeah. I'm going to make a little sketch of this, and we're on the interval 1, 3. Here's 1, here's 3. So these aren't going to intersect. Sometimes they will, sometimes they won't. And I'll map in a second, but it's basically two parabolas. One was up here, one was down here, just a rough sketch. And one was somewhere here, and 3 was like here. So what we're actually getting is the area between the two curves. So I draw a line at 1 between them, a line at 3, and here's what I'm finding. That's what it's going to get me. Okay, step 2, find any intersection points. There are none, they don't intersect. I should say intersect on our interval. I should add that. None on our interval. So finally, we'll set up our integral and evaluate. We're from 1 to 3, top minus bottom. So here's where you just got to decide which one's on top. And we've got two parabolas. You can look on Desmos or your graphing calculator, of course, but certainly this one is the positive x squared. So that's the top one. X squared minus 4x plus 10. Minus the bottom one, which is the 4x minus x squared. Notice I'm going to put it in parentheses. Okay, that's just like when we did, what was it, like the quotient rule? Back with derivatives, there's always minus in the second part. You have to do parentheses. Okay, so now it's back to FTC1. We're just going to evaluate. Well, let me clean this up first. This is really negative 4x squared and positive x squared. And so then let's just combine them and we'll do it. 1 to 3. I've got an x squared and an x squared. So I got 2x squared. Then a negative 4x and a negative 4x, which is negative 8x. And then a plus 10. By the way, have your graphing calculator ready. We're going to do this one by hand, but there are others starting soon, very soon today, that we're going to just set up and evaluate on your calculator. And I will certainly be clear on a quiz or test. I'll say you may set up and evaluate on your calculator, or I'll say set up and solve by hand. All right, so let's do this one by hand. FTC1 says we're going to do an antiderivative. Now, then I think back to our last, really 2 units. This is, I know the antiderivative of each one. I'm not going to need any other methods to solve. I'm just going to do power rule here. So I'll have 2, and then power rule with the x squared will be x cubed over 3. Minus, this is really 1, and so it's going to be x squared over 2, making it minus 4x squared, and then a plus 10x. So FTC1, I'm doing half of 3 minus f of 1. And we'll just plug them in. I'm not going to take time to evaluate all of these today, so let me just give it to you. When we plug in 3, you get 12. Minus, you plug in 1. And you get 6 2/3 or 20/3. 6.6 repeating if you want. Okay, and then when you subtract those, you get 16/3 or 5.3 repeating. Okay, we do one more trig one where the functions actually don't intersect, and then we'll do some intersecting ones. How about any thoughts on the first one, though? So you get a lot of similar things to the past, but f minus your top minus bottom. Okay. Let's flip it over to a trig one. This time I'm going to go ahead and graph them. I've got secant squared x and sine x. Secant squared x and sine x. Oh, I changed this here. I changed it back to radians. There we go. All right, and we're on the interval 0 to pi over 4, which is close to 1. So we'll leave it about there. 3.14 divided by 4, so less than 1. But. All right, so we're right around here. Sine is the black, the purple one is secant squared. So let me make a rough sketch of that. So I call this step 1. And there's a rough sketch on our interval. So sine was going like this, and well, and then go back up. So turn around there. And then secant squared was here like this. Okay, and we're on 0 to pi over 4. Here's 0. Roughly here, I think, was pi over 4. So again, you connect a line between the two functions at 0 and pi over 4. That's the region that we're finding. Step 2, not applicable here because we don't have any. The functions don't intersect. Okay, but step 3, we can integrate, set up an integral, and solve. And find the area between the two regions, between the functions, that region. Let's see, so we're going from 0 to pi over 4. And the top function is the secant squared minus the bottom function, which is sine x. I like this one. It shows it because it's a trig one, but also because here again, we actually don't need many methods here. We know these antiderivatives. Okay, so we're going to do this one by hand. We set it up, and we know these antiderivatives. So antiderivative of secant squared, tangent of x, minus antiderivative of sine, negative cosine. And yeah, you could just write a plus here, minus and negative. Okay. So that's the antiderivative. We'll plug in f of pi over 4 minus f of 0. Okay, so let's do that. Let's plug in pi over 4 everywhere here. So tangent of pi over 4. So where sine and cosine are the same. Yep, so it's going to be 1 plus, I'm just doing still on f of pi over 4, cosine of pi over 4. Radical 2 over 2. So that was the first one. Minus, so now when I plug in 0 here, tangent of 0 is 0. It's really sine over cosine. So it's sine of 0 over cosine of 0. That'd be 0 over 1. Plus cosine of 0 is 1. So yeah, I should really do this first. Okay. So let me leave the first one alone for now. 1 plus radical 2 over 2 minus, this one is 1. 1's cancel out and we get a square root of 2 over 2. Pretty cool. I always like when we have the trig functions, but that region there is actually not a whole number, but number with square root, anything like that. Okay, good. Next I'm going to do one with intersecting curves, so I should intersect. Anything I can answer on these first two, though? Okay, I'm going to say it a lot, top minus bottom. Okay. So this time, let's do one more that has the area is enclosed by intersecting curves. So far the curves haven't intersected, but now they do. The only difference is we want to find the points where they intersect. Okay, so we would notice here, we look at these, area of the region enclosed by these two functions. It doesn't give us an interval, AB. We're going to have to find it. Step 1, let's graph them. I'm not going to use Desmos here. These are a little easier to graph. Negative x is just the diagonal line through the origin there. And then 2 minus x squared. Well, negative x squared is parabola opening down. Okay, but then 2 moves it up 2. So what the y-intercept of 2, and then it's a parabola opening down. Again, if needed, you can go to Desmos or graphing intersect here and here is the values we need to find. We need to get that A and B value. And then what we'll calculate is the area, I'll put it in blue, the area between these curves. Right there. All right. So there's a little grid. The second step I do need to do, I need to find where they intersect. This was algebra 2. To find where they intersect, you just set the functions equal. I just set them equal. That's all. Now this one has x squared in numbers, so we're going to have to factor. Or what? Actually, I want to get things on the left. I'm going to get everything on the left. I'm going to add x squared to both sides. I'm going to keep the negative x. And then I'm going to subtract 2. Okay, then I'm going to, that's trinomial factoring. Numbers that multiply get -2, -2, +1. And those will add to get -1. So I get 2 and -1. And this tells me the numbers that go. So it's 2 here and -1 there. Right. So really this is the only new step, because now we'll set up our integral from -1 to 2, and similar as before. So yeah, integral from -1 to 2. Let's say the top function is the parabola. So that's 2 minus x squared minus the bottom function on that region is the line, -x. And so we can make that a positive x. Again, for this one, this is probably the last one I'm going to do where we're just going to evaluate by hand. We can do an antiderivative of this one. So the first one will be 2x, antiderivative of 2. I got minus power rule, x cubed over 3, plus, and then another power rule, x squared over 2. Right, well, f of 2 minus f of -1. Again, for time's sake, and just so we don't have to plug all these in right now, when we plug in 2 first, you get 10/3, or 3.3 repeating, minus, and then you get -7/6. You plug in -1. So minus negative with positive. When you add those, it's 4.5. Or 9/2. So again, as we progress here, this will be something Ada will have to do. Find the intersection points. Okay, have your calculator ready. I'm going to do 2 more just for today, and we're going to do, we're going to set them up but evaluate on our calculator. Any thoughts on this intersecting one though? Okay. So here's what's going to happen with these. The title there is boundaries with changing functions. Pretty much, let me sum it up. So far, what we've seen for this entire region, and for this entire region, and the previous one as well. For this interval, -1, 2, the red function was on top the entire time, and the line, which was the black one, is on bottom the entire time. Not going to happen in the future ones here. The top and bottom will change. Okay, or they could be different. They could be different functions, and so that would mean like different boundaries for these. All we're going to do is break it up into, I say, subregions. So this is like additivity problem. We break it up and have separate integrals for each region. Okay, so let's do this one. Find the area of the region in the first quadrant enclosed by these 2 functions, and note here, and the x-axis. So really, there's 3 functions. X-axis. So here, I'm going to put the x-axis, by the way, is the horizontal line, y = 0. So really, I said there's 3 functions. Quadrant 1, y equals 0, and d sub x 0. Okay, let's make a sketch. So quadrant 1 only. First function, x-axis, y equals 0. Already got that one. Second function is square root of x. And that one's more or less like that. And the third one is x minus 2, which is a line, but it has a y-intercept of negative 2. Alright, so here's negative 2, slope of 1, up 1, right 1. And again, this is just a sketch, but it's going to go roughly there. Let me make mine a little bit there, a little better. It's a little curved, sorry, it's not meant to be. It's a line. It's too curved. I have to do that. Okay, good enough. All right, so here's the problem with this one, compared to the last ones at least. The top function is actually the same, square root 1 the entire time on this region. Oh, and here, I should outline it. The region, here I'll put it in green, is that. First quadrant, x-axis, and the two functions. Top function is always the square root of x, but the bottom function changes right here. Up to here, the bottom function was the x-axis, it switches to the red line. So what we're going to do is break it up. I'm going to call that region A and this region B. And we're going to do each one separately. Let's see, so for step 2, let me do that first. For step 2, I need to find the intersection points. Well, I have a couple. We're starting at 0, I have that one. I do need to find where the red line meets the x-intercept, x-axis. So basically I need the x-intercept. So I can just set y equal to 0. Set the x minus 2, that line, equal to 0. And I solve and I get add 2, so we get 2. So that one's 2. And then I need this one over here. That one over there. So that one is where the red line, x minus 2, equals the black curve, the square root of x. Okay, so I'm going to solve this. Now this one, I need to square both sides to get rid of the square root of x. What happens over here is I need to square the whole thing. So don't just square x 2. I need to FOIL. And on the right side, square root of x squared is just x. Okay. So I FOIL, I get x squared. Negative 2x and negative 2x is negative 4x, and then a positive 4. And so it becomes a factoring question here in a second. So subtract x, I'll get x squared minus 5x plus 4, 0. Factor. Not always the same trinomial factoring, but in this one it is. Okay, so the numbers I multiply get 4, and add to get negative 5, negative 1, negative 4. So finally, 1 and 4. Okay, now the only one that we want is going to be the 4. By the way, this is actually, 1 is actually, I believe, extraneous. Let's see. Yeah. So do you remember when, this is back in algebra 2, when you're solving a square root equation, you have to square both sides. You can get extraneous solutions. So you actually have to check each of these. 1 minus 2. I'm trying 1 up here and seeing if it works. Equals square root. It doesn't work. This would be negative 1, and this would be 1. But if I try 4 up here, 4 minus 2 is 2, and square root of 4 is also 2. Sure, this one's extraneous. This one works. Long story short, we get 4. All right, so region A, integral from 0 to 2. Region B, integral from 2 to 4. By the way, my drawing is certainly not to scale there with the 2. Sorry about that. So I was trying to draw it over more. It just didn't happen. All right, so finally we set up, this is where we get multiple integrals. So the first one for region A is from 0 to 2. Top function is the square root function, square root of x, minus the bottom function is the x-axis, which is 0, y equals 0. You could also just not write 0 there if you want. Okay, then we'll add it, we'll get region B. So this is from 2 to 4. The top function is still square root of x. Sometimes it switches. No, it's still square root of x. And the bottom function is a red line. So we do minus, top minus bottom. The line is x minus 2 in parentheses. Okay, so here's where I said we're going to use our calculator. Again, I'll tell you quiz or test, like evaluate by hand or put on your calculator. Any questions on how I set this one up and then solve there and put them in here? All right, calculator time. If you don't remember, it's math 9. Is how we're going to evaluate these on our calculator. It's a good idea if you have your calculator here to try them out. As I'll do them as well. But so math 9, 0 to 2 is the first one. Oh, we have to double 0. Okay, 0 to 2 and square root of x. I'm not going to put 0. It's just 0 and dx. You can hit enter if you want. I'm going to just do them all at once. So plus another math 9. This time it's 2 to 4. And the second one is also square root of x. It starts, okay, but then it's minus the x minus 2. So let me go ahead and distribute. It'll be negative x and then plus 2. But you could have done parentheses there too. Oh no. Okay, hopefully I got it. Yeah. 3 and a third, 3.3 repeating. Your calculator is doing an approximate value when it does this, so that's why at the end it doesn't, it really is 3.3. Okay, also 10 thirds is 3.3 repeating. I'm going to do one more similar to this, a slight variation, but you can see we'll still have to find the intersection and so on. But thoughts before I do the last one? Okay. Well, one more. 2 functions. Find the area between these graphs, between these curves. Both continuous functions. Here's a closed interval. Now, what you might think is, oh, it's just going to be negative 2 to 5, top minus bottom. We got to look and see which one is which. Could be, but there's going to be something with this one that we'll see when we graph it. So if I graph x minus 12, x squared minus 5x minus, oh, that's 5x minus 7. And we're from negative 2 up to 5. So there, that's pretty good there. Okay, so there's the 2 functions from negative 2 over here to 5. Well, you could do top minus bottom, but the problem is right here. They switch. It starts as the parabola on top, line on bottom, and it switches. The line is now on top in this region. Line is on top, parabola is on bottom. And then actually, if we were going past 5, so if I did like to 7, we need a third integral because the parabola is back on top and the line is on bottom. So this can happen as well. Don't assume it's just one. It's just going to be one integral. Graph it, see if they change, and here they do. Yeah. So I'm going to make a little sketch of what we just saw. Okay, just so, and because I want to outline like really what we're doing. So is that parabola roughly in that line? And look, we went up to 5. And it started over here somewhere, like here was like -2. So let me outline what we're finding. I draw a line between the functions at -2. And those go to here, but then they're going to change. So I'm getting this region, we'll call it A. But then they change and they switch. And so from 1 to, that's not 1, I'm sorry, whatever that is, where they intersect up to 5, that will be this region, top minus bottom. And again, if we were going to like 7 or something, then we would have had a third region over here. Well, let me go back. Oh, we don't. Okay. Well, let's do it. I just need 2 integrals this time. I already have the endpoints, -2 and 5. So I already have where the integral starts here and ends here. I need this one, where the 2 functions meet. And so I set them equal. X squared minus 5x minus 7 equal to x minus 12. It is going to be another factoring one. I'll get everything on the left side. So I'll subtract x, -6x, and then add 12, and we'll have 5. Trinomial factoring, put an x in each. Multiply, get 5, and they need to be negative here, so -5 and -1. So we get 5 and 1. Now, first of all, this confirms that they meet over here. That's the end of the intersection there. That's good. And then it tells us that this right here is 1. Not drawn to scale. Not drawn to scale. So it should have been on the other side, but it was just a sketch, so it's fine. All right. Final thing, it's just sketch. Final thing is to set them up. So we'll have 2 integrals here. So region A, the red one. Down a little. It's going to be the integral from -2 to 1. Top minus bottom. So the top function here is the parabola, which is the x squared minus 5x minus 7, minus the bottom one, which is the line, x minus 12. And notice I put it in parentheses. Plus, then the next region is from 1 to 5. And it's just reverse. The line is now the one on top. So that's x minus 12. Minus the one that's on bottom is the parabola. So minus in parentheses, x squared minus 5x minus 7. Yeah. Again, it'd be good to try these out in your calculator. I will do them up here. It'd be good to try it out on your own. So the first one, math 9, is from -2 to 1. Okay, there's a lot to enter here. So, oh, and you also could simplify these first if you wanted. You don't have to though. Let's see, so x squared minus 5x minus 7 minus, I'm going to distribute, it'd be minus x plus 12. And dx. Again, you could actually combine those and simplify if you wanted. Plus another one, this one's from 1 to 5. And we're going to start with, I believe, the line first, x minus 12. Minus, and again, I'm just going to distribute the negative here. I could put in parentheses, I'm just going to distribute it. So it's minus x squared plus 5x plus 7. Make sure to put in the dx and hit enter. Okay, by the way, on these, it's, I'm fine with it like that. Sometimes people math enter have to change to a fraction. I like that as well, rather than a decimal. So either one is good though. 37.6 repeating for 113/30. Either one. Oh, I wrote that wrong. I'm sorry. 113. I made it worse. 113 thirds.